Wow guys, you made it to the last page of the Algebra 3H pack. Some pretty difficult topics in this pack, and we're going to round it off by finishing looking at geometric progressions. Okay, here are 4 nth terms for geometric progressions. You'll notice that these are not first term times common ratio to the power of something. These are just something to the power of something, but they're still geometric progressions. You could think of it as the first term being 1, so 1 times each of these things. So the first 4 terms of these, I'm going to write down the term numbers 1, 2, 3 and 4. Space them out a little bit because some of these might be big. So the first one, 2 to the power of 1 would be 2. 2 to the power of 2 would be 4. 2 cubed is 8, and 2 to the power of 4 is 16. Okay, so the common ratio there in that one is 2, which is this number here. Okay, in B we've got 10 to the power of 1, which would be 10. 10 squared would be 100. 10 cubed is 1000. And 10 to the power of 4 is 10,000. So what we're timesing by there is 10. And again, just to emphasize, that number there is this one here. On part C, 1/3 to the power of 1 is 1/3. 1/3 squared is 1/9. 1/3 cubed is 1/27. And 1/3 to the power of 4 is 1/81. So when we do something like that, by the way, we are doing 1 to the power of n over 3 to the power of n, which is those things. Okay, and 0.1 to the power of n is the same as 1/10 to the power of n. Okay, so 1/10 to the power of 1 is 1/10, or 0.1. I'll give it as a decimal since they have in the question. 1/10 squared would be 1/100, or 0.01. 1/10 cubed would be 0.001, and you get the idea, 0.0001 for the last one. Okay, number 9. S is a geometric sequence. All terms of S are positive integers. The first 3 terms are 8, x, and 72. Find the value of x. So, if we've got the third term and the first term, what we could do is divide them together. Now, just going back to how we write geometric sequences algebraically, we call the first term a. We call the common ratio r. So if we've times a by r, then this is ar. If we times that by r, this third term would be ar squared, and so on. Now, if we divide the third term by the first term, in terms of the algebra, that would be doing ar squared divided by a. And the a's would cancel off, just leaving us r squared. So r squared is equal to doing 72 divided by 8, which is 9. So we've found out that r squared is 9, so r must be the square root of that, which is 3. And it's got to be positive 3. Now, you could say that the square root of 9 could be negative 3 as well, and you'd be right. But because they tell us all of these terms are positive, if we said that r was negative 3, if we times 8 by negative 3, we would get a negative number here. But because they've told us they're all positive, r must be positive 3, and x must be 24. Okay, the challenge at the bottom here is quite a tricky question. I'll do the first one for you, and the method's much the same, and you can have a look at the other ones when I pause the video and show you the answers. But you've got to be really up for the challenge, grade 8, grade 9, definite sort of difficulty, these ones. Right, the way to do them is to look at consecutive terms. Alright, so if I divide the second term by the first term, that will give me this constant ratio r. So 2n divided by n minus 1 will give me r. But also, I can get r by dividing the third term by the second term. So 3n plus 9 divided by 2n will also be equal to r. So therefore, these two things are equal. And if these two things are equal, we've got an equation set up now that we can solve to find out what n is. So I want to get rid of this denominator. I'm just going to section off my working. I'm going to get rid of my denominator by timesing by n minus 1 first. Oops, probably can't see that. Alright, now what that will do is get rid of the denominator from the left, but it will put it up here on the right next to the numerator. And I've still got my 2n there. But that's the next thing I'm going to get rid of. I'm going to times by 2n, both sides. And I'm going to get, now I don't need to write brackets up here, I can just do it really. I've got 4n squared up here now. And if I expand the brackets on the right now that's left, I get 3n squared. The outer ones will give me minus 3n, the inner ones will give me plus 9n. So overall I'd have plus 6n. And then positive 9 times negative 1 would give me negative 9. So that's a quadratic I've got to solve. I'm going to get everything over onto one side so it's equal to 0. So I'm going to shift it all over onto the left hand side. So that would mean taking away 3n squared, which would just give me 1n squared. If I got the 6n to go over there, that would mean taking away 6n. So I'd have minus 6n on that side. And if I got the negative 9 to cross the equal sign, that would become a plus 9. And there we go. And now can I factorise this? Two numbers that times together to make 9, add together to make negative 6. Yes, that would be minus 3, both of them. So my solution is that n is equal to 3. Just the one solution there. Okay, so there might be, well, yeah, there are values of n, so there might be two solutions for some of these. Okay, I'm going to pause the video here whilst you probably spend hours working on them, and then I'll show you the answers. Okay, here's the answers, guys. Now, there was an error on question D somewhere. It didn't work. There was no way to get it to work, so that quadratic ended up being unsolvable. So it must just be an error in the question. I've checked where I got it from there, and it matches that, so they must have just made it with an error in it. Okay, but well done if you managed to get any of those. That's good work. Okay, thanks, guys. Shadow test up next.